Okay, I'm going to show you how to convert this into something else using something called a marking table. Essentially, this is just a weird name that someone's given this for what this is, which is called a minimizing construction. Let me just double check that I'm recording. Yay! I'm not going to waste my time. Essentially, they're exactly the same thing. It's just if you research it, you'll find it listed under minimizing construction, where there are two types, which is one that takes a lot of writing and you don't need to draw a table, and one where you do, which takes slightly less time, but it's not as useful if I'm completely honest, for larger automata. Throat's going a bit. So first off, what you want to do is you want to draw out your states. I've got Q0 through to Q3, Q1, Q2, and all these other ones. And what you want to do is you want to represent that here on your table. Then, because you got them twice, you're going to want to cross out all of the repeats. So you only have the bottom half. You can also have the top half, but that doesn't really matter which one you pick. Okay, that's thoroughly rubbed out. So now what you want to be doing is you want to follow this quick formula I've got for you here. There are some extra steps, but this is basically everything you need to do. So first, what you want to do is on your table here, you want to find a combo that contains one final state and another one which does not contain a final state. So and then cross it off in this table. So for example, you can see that Q1 here is Q1 right there is the final state. So what I go along this column, I find Q1 and I find any combination through this axis or this axis which has a Q1 or something containing a Q1 that does not contain another final state, and I cross that out off. So let me do that now. Cross that off. Cross this off. Let me hang on, I just realized I marked this down twice. Sorry, Q3. My mistake. Just bear with me, guys. So that's got Q1, Q3. These both have a combination of Q0 and something containing a Q1 stroke final state. So what I'm going to do is I can assume on this row that these are pretty much going to be all complete until I get to here, which has Q1, Q3. Now it's marked off here because you can't have doubles, but these both count as final states. So what I'm going to do is I'm going to leave that one alone. Lucky you. So now I've done that. It's pretty simple. I've marked off most of what I need to. Now then you've got the part 2 right there, which is of the remaining, if a combo contains one that transitions from a final state, mark, and then merge the containing marks. So what this essentially means is if I have of the remaining states one that transitions to a final state, then I also mark that off. So what happens is I look at my graph, I question myself, does this transition to a final state? Yes. So Q2, I go to my Q2 column, I cross these out. Now that's pretty good. But you've got these two remaining. Now this itself is a final state. So I've got to ask myself, does this transition towards a final state? Yes, it does. Transitions to itself. So it's off. Now I'm left solely with one box. You don't have to color this in. I'm just doing it for myself. Now, as it dictates that the God, I can't talk today. That the final combination merged, what is left over is merged together, and we get essentially something like this, where Q0 and Q03 is merged together, transitions to Q2, which transitions to this, which loops there and turns back there. Now you can tell inherently that this keeps all the same rules of this language that's found in this sheet as is found in this sheet. So you've now just completed everything that you would need to minimize this graph into this graph. And that is pretty much done. So if you need anything else, or if you nerds need to cram for a certain homework assignment the night before, subscribe or something.